Good evening, students. This is our 15th class. Today, we are going to learn some new things. So some supportive things that what we have learned so far. So before we get into that, do you have any difficulties or the problems up to now? So do you like to learn something specific? That means some different students can be interested in different studies or different areas, right? So if you are interested in learning something new today and tomorrow, we will discuss those things. So do you have anything to learn today? Do you want to learn anything? You can just ask me that we will learn. So I'm highly suggesting to you to invent some new things, right? And also register for the SLIC invention competition. As a student, you can register for only for rupees 500 from their website. I will show you how you can register, right? So you have to type slic.gov. I have also so this is not the one, this is one you have to type, right? This is their official website, so you have to type this one, right? In there you have to go to the events, right? And you have to click for Sahasak Nimavu, right? This is the upcoming competition. The deadline of the competition to apply is August 31st this year, right? So for the submission of the product or the invention is September 28th, right? So you can register into different categories as well, right? You may invent something in public safety, welfare, and national defense, physics, medicine, pharmacy. These are the categories, right? So you can visit this website and you can register for this competition, right? Right. So for the entry fees for the school students is only 500 rupees. You have to pay that one and then you can enroll it. This is their account number, right? So these are the things you have to have, right? So you have to have your details, right? The description of the invention. You have to type a short description about your invention. Patent information. If you have applied for patent, you have to provide this information as well, right? So and also in this time 2021, due to the COVID-19 situation, the competition will be held via online, right? So you have to show a video of your invention. You don't have to physically visit anywhere for this competition, right? So you can have a video maximum 5 minutes within 100 MB, right? So if you have any problems regarding the invention, I can support you, right? So you can ask me about your inventions or the ideas, right? And you can submit your invention, right? For all the best for your submission for this competition. I hope all my students will attend this competition and achieve more awards, right? So here you can apply. You have to fill a Google form and apply, right? On here in events, there are some more events as well, right? So young inventor, entrepreneur, lead development program, and also COVID-19 inventions also you can make. So these are the things you can apply for this website, right? That's up to you now. Right. In the meantime, do you have any problems regarding our previous lectures or doubts? You can, this is the time for you to ask questions. You can ask questions and learn something new. Right. The next thing that I'm going to tell you is what we have learned so far was very helpful for us to develop our skills and knowledge in the field of science, mathematics, and also ICT. That means information and communication technology, right? So if you open your book, right? If you open your grade 6 information and communication technology book, on there, the subjects, right? What we have learned so far, there are some subjects, right? So I'm going to show it to you in a bit, right? So importance of computers, these are the natural things. We didn't learn these things, but we have learned these things, right? So today we are going to learn this one, algorithm and flowchart in your ICT, right? So this is the thing that we are going to use, because in robotics this is very helpful for us to design and program robots, right? So this is the important thing. These things we didn't learn, right? In grade 7, right? Grade 7 ICT, right? So if you open information communication technology reading book grade 7, on there we have learned something from the book, right? So not from the book, but from us in the class we learned, but it is also there in the ICT class also, ICT book also, right? So I strongly suggest you to take ICT modules, right? I strongly suggest you to take ICT modules. Don't omit that subject, right? Just obtain that one. Whether it is hard or it is easier for you, just take these things, because information technology is the future, right? So we have to bring our country forward by innovating technological things, right? So for that we have to take this subject, right? So here we have a program development subject, which is under 46th page, right? So in that particular 46th page, I'm going to open that one, 46th page. Here we have the programming section, right? These things we have learned, right? So these are the some program development ideas, and this is the flow chart. So this is what we are going to learn today, right? Right. So here we have we have programs, right? So this is the Scratch 2.0, right? So they have introduced this software, right? How we can program, what are the components, etc. Right? So these are the things you can learn, right? So I hope you took these subjects in your uh, school and study these things, right? These things will be very helpful, right? I want to know how many students are taking ICT. Please let me know. Please let me know how many students are taking ICT modules in your school subject. So these are the things, right? So we have learned these things, right? So you can simply open Scratch 2.0 software, right? And you can practice these things, right? So these are simple things. Also, in grade 7 also, this is the grade 7 and grade 8 book also. they have this subject, this programming section, right? So this is under programming section, the 39th page. They have also given that particular programming sections. Right? Under programming, you can see that the programming continues even on the grade 8. Right? So you can see that they have created a game, right? So by using this program. So did you take this module? Please let me know, did you take this module, this ICT, Information and Communication Technology, in your subject? I need your answers. So can you hear me? So can you hear me?
Can, sir.
Yeah, did you take ICT? So here they have inserted some numbers, values, right? So you can simply go through this book, right? If you don't have this PDF, maybe you have your books with you, right? So if you don't have this PDF, I will give it to you in our class group. And also you can simply go to the website, the government website, and download it, right? Educational publication, this is their website, right? So this is their website, government website, edupub.gov.lk. You can simply go to this one and go to the under download section, textbooks download, right? So you can select your language, whether English, right? So your grade, maybe 6. Right here, you can download whatever the book you want, right? So if you didn't take the ICT module yet, probably you can take your ICT module in futures, right? In future, you can take, right? Right. So even in the 9th section also we have that programming section, right? Programming, this is the visual programming. And also, interestingly, you can open the 47th page, use of microcontrollers, right? So here we have the programming section as well, right? So you can see that for programming, this thing is essential. This is called as a flow chart, right? This one is important, right? So in order to program, this one is important. So that is what we are going to learn today, right? So here they have created the game, right, with the scratch, right? So this program will be helpful for you to create and program robots as well. We learned so far. Next thing in the book, grade 9 ICT, use of microcontrollers. They have the microcontrollers subject as well, right? So this is inserted in the new syllabus, right? In old syllabus, when we were studying this ICT, there were no subjects like this, right? But they have introduced these kinds of things for you, right? So here they have the Arduino as well, right? So what we have learned so far, they have inserted in their book also, right? So wires, the pins, right? The breadboards as well, right? So in the LED bulbs, sensors, you can simply go through this book and read these things, right? Right, in grade 11 and 10 also, they are basically students consider this subject as a hard subject, right? So, but it is not very hard, right? So if you learn with interest, It will be very much easy, and it will be very helpful for you to work on innovating things, right? Right. So, right, flow chart, right? So I can explain this from here. 55. Right. Algorithm and flow chart, right? Flow chart means this is a chart, right? Maybe it contains some shapes and other aspects, right? The flow chart means it will achieve our final goal, right? Maybe our final goal, whatever it may be, producing a cake, right? As an example, producing a cake, right? Producing cake. This is the output, right? In order to make this cake, right, we have to follow different paths. We have to follow a certain path in order to achieve that cake. Maybe we have to obtain sugar, we have to add some water, add some other components as well. But it should be done by step process, right? So in order to achieve the task, we have to have a step-by-step process. That particular step-by-step process is called as flowchart, right? So in order to make flowcharts, right, it is simple. We have to follow some rules. Right? These flowcharts can be used to simplify the program. Right? So if you want to program a robot, maybe the robot has to maybe obstacle avoidance robot, right? So we have to insert an ultrasonic sensor in the robot, and we have to program it, right? So if you directly go and program this robot, this may be difficult for you, right? In order to simplify the programming, before programming, we have to create a flowchart, right? We have to create a flowchart. Right? If you create the flowchart successfully, then we can create the program very easily, right? Right. So in the flowchart, we have three sets. The first set is input set. The second set is output set. The third one is process. Input means, right, for the obstacle avoiding robot, what is the input? Input is the distance, right? Maybe if there is any object is present, that this ultrasonic sensor is detecting it. That is called as the input, detecting the distance, right? So what is the output? Output is motion of the robot, this one. And if the sensor is detecting any object, it has to turn right in the right direction, right? So that particular motion, whatever, either maybe a forward direction motion or the rotating motion, is called as the output. That is altogether we can say that motion, that is the output. For the processing, that means it has to detect, and it has to say that to move the robots, that means the tires should be rotating, right? So that particular task, operate the motors, is called as process, right? So hope you understand about this one. So So that is what we call, right, a method that includes all the steps of solving a problem in order is known as algorithm, right? Order is important. The term order, right? So this is the step-by-step process, right? But the order is important. We can't change the order and make it, right? That is called as algorithm. Step-by-step include step-by-step of solution of the problem with order. That is called as algorithm, right? So do you have any problem? You can ask me, right? So here we have to create a flow chart for this one. Create fruit salad are as follows, right? So today we are going to create a fruit salad with the flow chart, right? So before we get into that, right, I'm going to introduce these kinds of symbols, right? In order to draw a flow chart in a standard way, we have to use these kinds of standard symbols, right? The standard symbols means these are the symbols. That means this one, this particular one is called as a start or end symbol, right? Used to indicate the start or end, right? So if we want to start, maybe we can say that this is the starting point of this one, right? I will show you in the example so you can understand this symbol, right? So next symbol is this one. This one is used to indicate the input and the output, right? Maybe example, entering the student's marks, serving fruit salad, right? In our case, what is the, in our obstacle avoiding robot, what is the input or output? This, what should be written inside this one? Can anyone tell me what should be written inside this one? It's very simple, right? Read sensor. This is the input. Reading the sensor. Maybe the particular sensor may be attached to the fifth pin in our Arduino. So then we have to use this one, fifth pin. Read sensor's fifth pin is the input, right? So we have to use this symbol, right? It is not a box shape one, this one, rectangular one. This is a like a parallelogram, right? Right. So this one, this particular symbol, rectangular shaped one, is used to show an action or a process, right? So maybe action means adding eggs one by one to the mixture of sugar and butter and beating it, right? So this is not the input. This is to say an order, right? This is an ordering. That means you say that this is a process, right? Maybe rotating the motor, right? That those things, right? Right. This one is very important, right? This is the one used to make decisions, right? So this diamond shaped one, we may have two solutions, right? So yes solution or the no solution, right? As an example, right? If the first number is greater than second number, right? Maybe if the first number is greater than the second number, if it is yes, then we have to go in this path. If it is no, we have to go in this direction, this path, right? As an further example, right? So in here, right? So in our same example, maybe the obstacle avoiding robot, right? If any object is present in between 1 meter, maybe 1 meter or 50 centimeter, right? 1 meter, if any object is present, right, within 1 meter, that is the decision making step, right? For that, we have to use this symbol, right? So we have to type here if sensor, right, detects within, you have to write it, right, within 1 meter range. So if yes, we have to write it, right? So it is important. We have to indicate that yes and no, no annotations, right? This is very important. Yes and no, right? So if the sensor detects the object within 1 meter, then this will happen. That means the motor will rotate. That means this motor will be idle and this motor will be rotating. That means the robot will turn in this direction, right? We learned these things, right, in our previous class. And if this one, if sensor is not detecting, then what will happen? It should go forward direction. So both the motors should rotate. That is the case. This is how the flow chart works in decision making symbol, right? So next thing is arrows. These arrows, right? So it is used to indicate the direction of the data flow. It is must. It is the must to put an arrow. This one, this shape, arrow direction, right? So we have to place this one. This is very important. We can't insert the arrow in this direction, right? That means we have to mention the direction, right? That is very important, right? That is all about the symbols, right? Now we are going to work on that particular activity, right? Right. So we are going to make fruit salad today. So as an example, step one, in order to make a fruit salad, finding various kinds of fruits. We have to find various kinds of fruits. That is the step one, right? Now, then washing all the fruits well. We have to wash those fruits, right? Third thing is cutting fruits into small pieces, right? After that, putting the pieces of fruit into a bowl, right? So this is the fourth step, this one, into a bowl. We have to put those cut fruits into a bowl, right? Then we have to add sugar and mix. After that, serve the fruit salad in bowls. We have to obtain another glass, maybe a bowl or a glass. Then we have to serve it to our maybe a customers or for ourselves. Right. This is the process. Right. This is the process, step by step process. We have to draw a flow chart according to this one. Right. So here, this is the flow chart. Right. So here, start. We have to set initially. We have to set this particular symbol, right? Called as eclipse. Sorry, ellipse. Ellipse. This one, start and end. In between, we have to write our program, our flow chart, right? Right. In our flow chart, getting various fruits. This is an input, right? So that is why we have placed a shape like a parallelogram, right? Inside the parallelogram, we have to type getting various fruits, right? After that, we have to say order. We have to order that one. That means we have to say that wash fruits well, this one. After washing is done, then we have to place an arrow symbol here also, right? After washing, cut fruits into small pieces. After we have cut, put the fruit pieces in a bowl, right? We have to put it into a bowl. Then add sugar and mix, right? Serve the prepared fruit salad. This is the output. if it is an input or an output, we have to use this kind of things. After it should be end. This is how we write a simple flowchart for the process, right? So I'm going to give you another example for you to type, right? So yeah, we don't have a example here. So I can give it to you in another way. Right. So this is the second example that we are going to see, right? So for example, let's consider an instant where a ceiling fan is operated, right? When the switch is on, the ceiling fan operates. If there is power, if there is no power, the ceiling fan doesn't operate. Did you understand this example? I will tell it to you again, right? So a ceiling fan has to be operated, right? When the switch is on, the switch firstly the switch should be on, right? So after the switch is turned on, if the power is on, that means the another switch, right? If the power is on, then the fan should work, right? If there is no power, then the fan will not going to rotate, right? This is the scenario, right? For this particular scenario, we are going to design a flowchart. If you can draw a flowchart like this, we can easily program this anything. So this is the small example, small and simple example. If you can make this kind of flowchart, you can make program, right? So that is why we learn this one, right? First of all, we have to start. Click, insert a symbol, start symbol, right? Start. Now we have to draw an arrow, right? Then we have to say that maybe this is the switch on, this is the process, right? So you can simply draw a switch on rectangular, switch on, or instead of that, you can also insert this one, right? And assign a variable to this one, right? So maybe that is called as a read switch, maybe X, or maybe read switch digital pin 1, maybe whatever, right? You can insert this one, right? So I'm not going to do that one. You can make, right? So here, switch on, right? Switch on. This is an order, right? So then after switch on, right? We have to take a decision, right? We have to take a decision, if decision, right? If power is available, right? If the power is available, right? Then no, this will happen. If the power is available, if it is yes, then this will happen, right? So for the yes condition, we will analyze, right? If the power is available, yes, that means there is a power, right? If the power is available, what will happen? The fan will be rotating. That means the fan is functioning, right? Fan is functioning. So probably this should be in this one, right? So fan is functioning, right? So no means, that means no power, right? No power means fan is not functioning, right? And then it will go to the end. This is the program. And also you can increase the complexity of the program as well, right? So I'm going to delete this one and I'm going to say another one, right? Another one. turn on power. Turn on power switch, right? Then it will come to what? It will come to this one. Fan is function, not this one, or maybe you can make the arrow to this one, this particular point. Then what will happen? If the fan is not functioning, if no power is available, no fan will not going to rotate, right? So for that, turn on power, maybe the power switch, right? So after you have turned on the power, the fan will be functioning, right? So that means we can end up with the program with the working fan, right? This is how we can interact with flowchart and make according to our requirement, right? Do you have any problem with this flowchart? You can ask it to me, right? So also, if you can look this one, start, take a till to put money, right? Take a till, maybe obtaining the money, the coin, put money is still full, right? This one, right? So if this one till is full, what will happen? If the till is full, that means it should end the program. We can't insert any other coins, right? So if the till is not full, that means we have to put money, right? So we have to put money. That means this is called as a loop, right? It will be happening forever until it comes to yes, right? The loop will be running until this function is coming to yes, right? If it is yes, is still is full, then it will go to yes. After it is yes, then it will stop the program, right? So this is filling a till, right? So similarly, we can make programs, right? So whatever the flowcharts, the usage is limitless, endless, maybe, right? So you can make whatever the flowchart according to this one. Even if you are inventing some new things for your Sahajak Nimavum project, right? That means the inventors commission competition, you have to create a flowchart, and the flowchart will easily describe the situation of the working principle of your invention, right? So definitely you have to make a flowchart, and after the flowchart you can make the program. You can easily code Arduino, right? So that is very simple, right? So simply we can make that, right? So start, take a pen, write, is ink finished? Yes, then it will stop. If the ink is not finished, then write. This will continue. Similarly, we can make a lot of projects, right? Right. Do you have any problems regarding this one? You can ask me. Vinuke, do you have any problem?
No, sir.
No, sir.
So do you understand about the flowchart?
Yes, sir.
So shall we play a game?
Okay, sir.
Right.
Okay, sir.
Right. So today we have this one, the particular, can you remember our second example? That means we have two switches, first switch and the second switch, right? This is the red LED, right? This is the blue LED, right? So we have wiring diagrams and all the other steps, right? So here we have an Arduino, right? So maybe instead of this switch, we can have a sensor, right? This is a motion sensor, right? This is a what we call this is an IR sensor, right? A, this is A, this is B. If the motion sensor is detecting, that means if any person is moving, then the red LED should blink, right? If the IR sensor is detecting, that means the blue LED should turn on. This is the scenario, right? You know how to wire these things, right? We have learned so far how to wire these things with Arduino, right? We know that one, right? Now we have to program that one, right? Before we program that one, we have to create a flowchart, right? Now I will start from here, right? And each and every person, right, from to the class, you have to complete this flowchart, right? So here I start this one, right? So here I start this one and I am inserting, right, this one and read sensor A. That means the motion sensor is reading, right? Then the person, the second person, maybe Binuka, is going to continue the next symbol and the next annotation, right? Binuka is going to write the second step. So what is the second step?
Sir, we should send the signal to the Arduino.
Yeah, so that we have to have a decision, right? So you can draw this one, right? I'm going to give you the, I'm going to allow you to draw this one. You have to draw this and complete this one, right? That is the task. You can draw this one here. You can draw and write. So quickly. Yeah, he's drawing. So what are you going to type? So simply you can explain and type.
Send signal to Arduino.
Yeah, that means if the sensor is detecting, right? That is what you are going to write, right? If the sensor is detecting, right, that means the Arduino should give the power to this LED to blink. That is the simple thing, right? So you can type sensor, right? So simply I can type if A is equal to 1, right? We know that in our sensor we have two values, 0 or 1, right? So if A is equal to 1, then yes means this will happen, no means this will happen, right? So next person Ginure Gikianage is going to type the flow chart for this one, yes function. If A is equal to 1, what should happen? Now Gikianage, you can draw this one. You can draw this one. If it is wrong, we will discuss later. No problem, right? I'm not going to bother you. So you can just simply draw. You can explain it also to me.
It switches on.
Yeah. This one, the red LED should turn on, right? So you can type that one. You can draw that one. We'll see how you draw that one. Can you draw?
Sir, but I can't type in it because my font size is Little bit
Okay, no
clearer.
problem. Just tell me, just draw the symbol. What symbol, what particular symbol you have to draw? That is what I want. This one or this symbol or this parallelogram symbol. What is the symbol? Or maybe this symbol.
The oval shaped one is for the end.
No,
So I think that
no, we are not going to end the program, right? Oval shape is this one. The ellipse shape is used to end the program finally, right? So this is not the end, right? So we have to give an order. We have to give an order for the program, for the flowchart, right? For that, we have to give this one. That means rectangular shape. Maybe I can obtain this one, right? So this one, and type. Maybe I can type. If it is yes, then maybe the red color LED is maybe attached to the third pin. Maybe what should happen? The third pin should be high, right? So that means I'm writing here red LED on, turn on, right? This is the program. This is the step, next step. Then after, if then okay, this is happened. What do we have to connect this one, right? So then we have another option, no, right? If A is not equal to 1, that means the sensor is not detected. What should happen? Then it has to go to this sensor. It has to go to this, maybe read this sensor. Sorry, this is not this one. That means read sensor B. Do you understand? If the sensor A is not detecting, we have to read B sensor, right? So then we have another option here, right? We have another option here. On that particular option is showing that if B is equal to 1. If it is yes, this will happen. If it is no, maybe another will happen. Maybe no. This is yes. Right. So if it's no, read sensor B. If it is yes, red LED will turn on, and this one will be connected to this one. After the LED is turned on, then it will go to read the sensor B. Right? So then if B sensor is detecting, the B sensor value is 1, yes, what will happen? Can another one tell me? Sandali, can you tell me that what do you write here? What will you write here? No problem whether it is correct or not, just tell me the answer. What will you write here? So you will write, right? You will order similar to this one. That means if A sensor, that means motion sensor is detecting, the red LED will turn on. Similarly, if this IR sensor is detecting, the blue LED will turn on. That is simple, right? So for that, we have to write blue LED on. Blue LED on. This is the program, right? So after that, right? After that, we have to do what? We have two options, right? We can obtain this one and connect it to this one. If we connect like this, what will happen? This will running forever. That means it will not going to end. After it will read. It will not going to end, right? So that is the case, right? Or in other way, we can end up this one, right? So maybe we can obtain end function, end symbol, and end. So this will happen only for one time. It will read a sensor. If a sensor is detecting, then LED, red LED will turn on, right? Then it will go to read sensor B. Then if the red sensor is reading, that means B sensor is detecting, blue LED will be turned on. Then it will go to end. But we have to complete this one, right? So here it is incomplete, no section, right? For that, if it is no, then we also have to connect this to this one, end, then end. Similarly, we can play around with these flowcharts, right? So you can now you understand how we can create flowcharts, right? After you have created the flowchart, you can write programs, right? So here we have to have if symbol for one time and two time, right? For that, in your Tinkercad software, right? So in your Tinkercad software, right? Circuits, create a new circuit. We are going to connect this one, design this one. Right? So Arduino, we are going to insert here. Right? Breadboard, we are going to insert here also.
Excuse me, sir.
Yeah.
Sir, could you erase the flowchart?
Yeah, we can erase, but obtaining is hard. Right? No problem, we can erase it. Right. So quickly, I'm going to insert a motion, maybe this one. Maybe we can place it here. Have to. So here we don't have IR sensor in this one. We also have IR sensor here, right? Infrared sensor, but this infrared sensor is not work according to our original IR sensor, right? This one will work according to the remote control, this one, right? So I'm not going to use this one. Instead of that, I'm going to use a temperature sensor, this one, right? You know that all the sensors are working similar, right? Wiring diagram is simple, right? So LEDs. So I'm going to insert two LED bulbs, 1 and 2. This one is red and this one is blue, right? This one is blue, right? Now wiring part, we have to obtain a 5 voltage and give it to this one and ground this one, right? Now we have to give power to this one. This is the power terminal. So connect here, negative terminal, connect it to ground, this one, right? Now this is the signal pin. We have to connect it to a Arduino, maybe this one, right? Similarly, we have to wire this one. So simply we can have V out. This is the power. So this one is ground. We have to ground it, right? This is the signal, V out, right? On that V out, we have to connect it to this one, right? So then we have to obtain this one, maybe 8 pin, right, and connect it to this LED and ground it, right? And also we have to obtain the 9th pin and connect it to this LED and ground it. You can make it beautiful, right? But I'm going to explain it very quickly. That is why I have wired like this. You can make it beautiful, right? Now we are going to code this one. That is what we are going to do, right? So coding is very simple, right? We have two if functions, right? So we have to open if and then function, right? So if and then function, we have to use if and else function, right? So I'm going to delete this one, right? So this is what we have to create, right? If function, right? So on that particular flowchart, we know that if this sensor is detecting, that means this LED should turn on. If this sensor is detecting, that means this LED should turn on. That is the program. That is the flowchart. By seeing the flowchart, simply we can program it, right? If this sensor, right? This sensor. That means if we have to create a variable, we have to create a variable. That means the variable I told you A, right? So A, and also we have to create another variable for this sensor is called as B, right? So now we have to initially set this A to 0, and also we have to set initially for B to 0, right? Now we have to, so we have set initially A. Now we have to read that one. If you see the flowchart, what did I write? What did I write? The flowchart, I wrote this one. This one, read A. This is what I have written. Read A, right? So here we have to set that, read A. So input. So that is why I have clicked input and read digital, maybe digital or maybe analog. I don't know. Maybe digital, right? So we have to set that read pin, right? So read pin for what? Read digital pin. What is the pin? 2, second pin, and on the B output sensor is fourth pin, right? So that one is read digital pin number 4, right? After that we have an if function, right? If function for A sensor, right? So for that we have to go to math function, right? And on the math function we have to drag and drop this one, right? So if the sensor is detecting, that means if the sensor is giving 0 or 1, that means 0 or 1, right? So that is what I'm going to write here, right? So go to variables, and this variable, if A is equal to 1, what will happen? This will happen. Else this will happen, right? So if it is A is equal to 1, that means the sensor is detecting, this LED should turn on, right? For that we have to go to output. If you see the flow chart, you can simply write the program, right? So for that, set pin. What is the pin? This pin. This pin is, what is the pin? 8th pin. 8th pin should be high, right? If A is not equal to this one, what should happen? It should go to, what will happen? We have another if function here. We have another if function. Then we have to go to if and else function. This function, right? Else if, right? Similarly, we have to have a math function. Then we have to go to read the B sensor, right? If B sensor is equal to 1, then it should happen. That means this LED should turn on. For that, we have to click this one and this one, place it here. The pin number, that means this pin is 9th pin, right? So 9th pin should be high. Else, that means even this is not happening, this is also not happening. That means what should happen? It should go to N now, right? Else, I can set it that both the pins should be low. This one is also low, this one is also low, but 8th pin and 9th pins, these two pins should be low. That means should be turned off. After that, after it is reading this one, it will run. We will check whether it works or not. If it is not working, we have to correct. If it is working, that's fine. Right. We have to trigger this sensor. Maybe you can see that if the sensor is detecting, that means it will give the value to 1. Right? We have to put a resistor in between that one, right? Right. Then also, if the temperature sensor is detecting, that means what is the problem here? Can anyone tell me why the LED is not turning on? Can anyone tell me why the LED is not working?
Because we haven't connected all 3 terminals.
No, we have connected this one. This one is connected. Connected. Here, power, ground. We have connected. I'm expecting another answer. This one is also connected. No problem. But the problem is, can anyone tell me? Another try. So here, the temperature sensor is not a digital sensor, right? This is an analog sensor, right? So we have to connect this sensor in the analog terminal. Then only it will work, right? So stop simulation, and we have to obtain this one into remove this line, and we have to connect this to an analog pin, this pin, right? Now we have to edit the code. We have to edit the code, right? Edit the code, not B sensor. This B sensor read digital, not this is read digital. This is read analog. Read analog, A node pin, right? A node pin, right? Now we can set this as if the analog pin, A node pin is 1, we can set this. Right? Now it will work. So here the values are different. That means we can't set that B is equal to 1. Right? We have to set this as a greater than. So it varies in between 0 and 1023, right? So that is the case. So we have to set a threshold, right? Maybe 400, right? Is less than 400, then it will work, right? So if it is less than 400, it will work. So more than 400, it's not going to work. The threshold is important, that right? I think the threshold is 256, 255. For that, we have to set this as 150. Yeah, that is the threshold. So in analog sensor, the threshold is 0 to 255. right? So that means we can change the value between 0 and 255, right? 255 means in the digital signal it is like 1, right? 0, it is like 0, right? But in between, if you want to change the values in between this one, we have to scale it, linearly scale it, and we have to type the value, right? Right. This is not the temperature value, right? But this is the voltage value. Hope you know that voltage means uh, this is the mapping we call as map, right? 0 to 55, right? So here I have inserted 150, here 150. That means in Arduino, it will be look like as 0 voltage and 5 voltage. In between 150 means, so similarly, if you extend this line and if you see this one, it may be maybe 3 voltage. It's not accurately 3, but maybe 3. Right? So it will, the Arduino will recognize the 3 voltage, right? According to the temperature difference, the value will be rotating, right? So even in the sensor's perspective, right? The sensor's perspective, maybe the sensor's range may be 0 to 100 degrees Celsius. You can see the units, right? The sensor will detect the units. So 0 degrees Celsius to 100 degrees Celsius, right? So if it is this one, in between this one, maybe 60 degrees Celsius, if the sensor is reading 60 degrees Celsius, then the sensor will send a signal of 150. That way, Arduino will recognize as 3 voltage. This is how it works, right? This is what we call as mapping, linear mapping, right? Right, that is the idea. So this is the value in programming we have to write, right? So if you write 0, that means this one. That means 0 degrees Celsius. Arduino will recognize 0 voltage. If you write 100, that means maybe in between this one, right? So this one, maybe 40 or whatever, right? So we can calculate this by using a formula, right? So maybe this one is X, this one is Y, right? So X minus 0, X minus 0 divided by 100 minus 0, 100 minus 0. That is equal to y minus 0, y minus 0 divided by 255 minus 0, minus 0. If you simplify this formula, you can get, right? So for that, if this one is known value, maybe 30, let's say 30 degrees Celsius. So what should we write in our program? That is called as y. In order to find y, we have to substitute 30 in x, right? So that means 30 minus 0, that is also 30, divided by 100 minus 0, that is also 100, is equal, y minus 0 is equal to y divided by 255, 255, right? If you obtain the value for y, that means these zeros cancel out, this one. 3 times 255 by 10 divided by 10, right? That means, what is the value? 765. So you have to type 76.5 in your program, right? In your program. That is how it works. Right. So that's all up to today, up to now. So do you have any problem? Do you have any questions to ask me? You can ask. So,
questions.
so what are you going to learn tomorrow? Do you want to learn any specific thing? Maybe your project or maybe programming or what? What are you expecting to study? Okay, it is better to discuss these things in a group, right? So we will wind up the class today, and we will meet in our final class of basic robotics course. So I will upload the Google form in our group. So please fill that Google form, feedback form, right? So please fill that one. Thank you.